Cool. All right, well, it's my pleasure to announce Mr. Ellis Ware from AgQ to tell us more about combat robotics 3D printing. Take it away.
So, thank you very much. Well, thank you very much for deciding to spend the next 30 minutes of your life with me. That's a lot of faith that you're putting in me. I've never done this thing like this before, and I have definitely not massively opened my head. I've got 40 pages of notes here, so you seem looking off to the side. That's where my eyes are going. I'd like to start by talking about something that I'm really passionate about, and it's something that I find I can kind of easily come back to as a topic because, as I say, it's something that interests me greatly, and literally my enthusiasm for that subject comes across. It's me. I'm going to talk about me, if that's all right for a minute. I've been told that for doing this sort of thing, I ought to, not try to be too humble, talk a little bit about what I've done, where I've been, and give you some context for what I'm going to hopefully take you through for the next half an hour or so. So, hello, my name is Ellis. I just turned 30 somehow, can't believe we're saying that. And I've been a professional engineer for about a decade of that, again, somehow. And I've been designing and building fighting robots like these for about 15 years. I am somewhat online in the 3D printing space. It's possible that some of you in this room will have seen a giant Lego Spy Christmas tree. That was a collab I did with Ruth from Kids Invent Stuff, Christmas 2024. Went semi-viral on TikTok and was a 3-week project that, with 3 weeks, I'm never going to get back. Oh, I just realised you're sitting over there. And also had the pleasure of being on a TV show called Masters of Reinvention, also with Ruth.
We don't do everything together.
2024 was a busy year. And so, yeah, I've been around a little bit. I've actually taken a fairly bizarre route into the world of engineering. The writing was on the wall when I was a kid. There's a video somewhere when I was 2 or 3 years old, taking the batteries out of an RC car and putting them back in the right way around, plausibly. The story of all of that was essentially, I realise that's the wrong one, was essentially TV shows like this. So if you're in the UK, these will hopefully ring some bells for you. The big ones, obviously Robot Wars, but there was shows called Techno Games, there was Scrappy Challenge as well, Art Attack, a little bit of Smart and Blue Peter. I was destined to be a nerd. The shows were all great. I cannot overstate how much Robot Wars was a very big part of my life at that age. I had the video games, I had all the toys, I had the really rather terrible pencil case that I used in school for far too long. That was really, really cool. And I was making things all the time. So that's that Robot Wars. There's a Robot Wars arena there that my parents literally built for me so that I could play with the pullback toys as a kid. And yeah, I was always making aeroplanes and whatever it might be. There was nothing in my house that was safe from being potentially turned into something. No toilet roll tube went unused. And those Legos, I didn't know that picture existed until my mum said it to me, but they looked suspiciously like Robot Wars relics to me, or my attempts at them. It's a long story, so I won't go into it now, but Robot Wars was cancelled in 2003, the original run of the TV show, much to my sadness. And in a similar sort of time, I actually moved to the south of Spain. Just for a bit of context, I would say, ironically, Jane Root, the lady that used to run BBC Two, is the person responsible for cancelling Robot Wars, and she's a distant relation on my granddad's side. But we don't talk about it. In that time, I was trying to find as much Robot Wars content as I could, and naturally that led me online. And I was browsing online looking for Robot Wars stuff, see if it still existed. And I came across this website, you guys may have heard of it, YouTube. I was on YouTube, inevitably searching for Robot Wars content, and it was on YouTube that I discovered that it still exists, even though it wasn't on television. So it still goes on in convention centres, it goes events like this, and leisure balls, that sort of thing, for the enthusiasts, by the enthusiasts, even though it wasn't on TV. So the hobby still existed, essentially, and I was quickly realising at that time how much, as I got more and more online, was happening in the world outside of that little village that we moved to in Spain, in terms of engineering, in terms of the interests and hobbies and whatnot. I did what everyone does in that time, in that era, which is I joined online forums, and I started being incredibly annoyed on one particular forum for about 4 years, which was called the FRA, the Fighting Robot Association Forum. The truth is, I was also struggling a little bit in school. I was struggling to find things in common with some of my fellow students. And as I say, I kind of gradually became more and more online. I was making friends all over the world in the USA and stuff, and I had lots and lots of hobbies that were outside of building things. I was into animation and video editing and whatnot. And again, there wasn't an awful lot for me in that little village that I was living in Spain. For various reasons then, at the time, my parents and I had a very serious conversation, and we agreed to pull me out of school when I was 15, and I did an online run school, which was UK-based, for about 9 months. I had one exam that I passed ever, which was an A-star in Spanish, logically.
Yeah.
So anyway, I think it's important that I give you some context in terms of what robot combat actually is. It's divided into 6 main weight classes. The numbers are on the screen, but these are, as you can see, are all different shapes and sizes. The biggest ones, the ones on TV show, are heavyweights. So if you've watched Robot Wars or watched Battle Dogs, that sort of thing, they weigh 110 kilos in excess of 240, 250 pounds. The featherweights, which is this orange one at the back here, weigh about 30 pounds or 32 kilos, and they get progressively smaller. Here today, with our cube downstairs, you've got fancy plate, we've got hand weights, which are a section to smallest that are regularly used in the UK at 150 grams. You skip out. The whole thing with robot combat, right, is that it's violent. And so it's very easy to only see that and only see, oh, it's destructive. The idea, if you're not familiar with it, is that hobbyists, enthusiasts, engineers from around the world will spend a lot of time, potentially a lot of money, designing and building fighting robots for the purpose of fighting their fellow builders of said things. And as I say, it would be easy to only see that it's about engineering or it's about the violence of it. The context is that you're trying to beat your opponent, not only directly, but also that you might have a panel of judges, and it works like many other fighting sports. The truth is that it's an incredibly educational hobby. I know it's I'm joking. So ideally, a robot is optimized. So the idea is that you're operating within a weight limit, and that kind of drives everything. So you want your robot to be as damaging and as protected in terms of armor from other machines as possible. But of course, you've got to do that within the weight. That promotes a lot of optimization, specifically to do with materials and power to weight ratios and that sort of thing. The journey of trying to build a better and better robot can be incredibly educational. So yes, there's all the obvious engineering stuff. There's CAD software. There's materials, that sort of stuff. But what you may not necessarily appreciate is how much it can teach you about life skills. So these are expensive, like I mentioned. So managing your finances, managing the budget you've got. They are almost always built last minute. So deadlines, time management, and resource management are a huge part of it. And the whole point is that you do this with friends, with family, as a team, potentially. So, of course, you learn to work with others. And the point is that from a life skills point of view, I didn't go to school. I kind of replaced it with robots building, and I more or less just about turned out okay, I think. After a few years of that cycle, it come to about late 2015, I got a message from a friend, which was that Robot Wars, the TV show, was actually coming back. So by this point, we moved back to the UK, and before that, it was convenient timing. And essentially, the proposal was given to me that if I could design and build a robot in a matter of 9 weeks, that I would be able to enter Robot Wars. So this is the machine I built in 2016. It's made entirely out of military-grade steel, weighs 100 kilos, as I say. We couldn't bring those today. Logistically, it's a bit tight downstairs, wouldn't really be viable. Certainly wouldn't be able to do a demo with them because they are obviously very loud, very scary. Just a brief note, let me tell you, if you're a 19-year-old and you're nervous about calling up local businesses to try and help pay for your silly fighting robot, getting on the phone and asking for money is an especially well sorted method of learning how to do that, because asking strangers for please can I have sort of cheap, strong method for free is a good way to kind of grow up in that sense. And so it continues. This was version 2 for Robot Wars, and the stress and sleep deprivation, all that, lots and lots of life lessons being learned. My record was a 42-hour build streak, and it culminated in building Magnetar here, which has a few 3D prints in it, which I'll get to in a second. And as I say, it was around 2017. Finally, when I was 21, I got offered a job in London as a product developer, designing and building all kinds of products, using the skills as a direct result of building fighting robots. So I've managed to just about come full circle despite not going to school. And then briefly, I also had some fairly mad love experiences out in Shanghai. Shanghai and China had several versions of Robot Wars out there. I flew 3 times out there and also managed to make it to Vegas for robots. So I joined the unofficial Triple Continent Club before things settled down a little bit in most of the TV shows. Unfortunately, are currently off air. So hopefully that's a little bit of context of what robot fighting is and where I've come from and why I've been doing it. And I'm going to start talking about 3D printing now. So, as I mentioned, I was starting to introduce 3D prints into these machines about 2015, and my very first 3D printer was I don't know if anyone's ever heard of or used specifically the Hobbit Fabricator from 2015. I was going to ask for wood, but I don't think that's good work. It was not very good. It had all of the components that made it look like a good 3D printer. It's actually really nicely made, injection molded. But it was based on the credit frame, and that is literally my first 3D print ever, I think, or first attempt at one. I managed to find a picture. So it wasn't very good, but it taught me a lot about 3D printing. It taught me a lot about exploring some of the materials for the purpose of using them in fighting robots. And it taught me a lot about 3D printer hygiene, all the stuff that we've dealt with, stuff not sticking to the bed, the nozzle being clogged, whatever it might be. Trust me, I learned how to deal with that on this old printer. So it's 2015. And it's PLA's world. Back then, we didn't really have access to affordable engineering materials. You could get them, but the reality was, if you're at home, you're using a hobby printer, you're probably using PLA. ABS is a possibility as well. Notoriously difficult to print, especially on modern, especially your 3D printer. And if it's not already clear, Robot Combat is violent, and it's all about shocks and G-force, things flying around. And if you have anything in your arena that is brittle or is likely to fail catastrophically, it will guaranteed happen at some point. So PLA, as strong as it is, it's really stiff. It's very good for lots of things. Very, very good. Prototyping was only really good for exactly that. It was only really good for prototyping or testing fits, that sort of stuff. Because if you put it in the arena and hit it with something hard enough, it would essentially shatter like glass. The progression of that was essentially just maximizing what we could. So I was using XLS nylon at that time a little bit, and I had friends print things out of ABS, but there wasn't really an awful lot that you could do with PLA. So I first put a 3D print inside a robot in March 2015. It was a pulley sandwiched by some metal, because again, I didn't trust the pulley on its own. I used transmission systems that are full of timing belts, and of course, timing pulleys are very difficult to manufacture. So ironically, this was actually quite an exciting time for a very relatively simple part. Being able to make complicated things like pulleys in robots using 3D printing was kind of already a bit of a game changer. I didn't print those. I had a friend print them on Azure tracks in ABS or some material like that I couldn't print on my old fabricator at home. I think when I eventually did, I used VIA Plus from Rigid Ink, but it remembers that filament brand, a fallen filament brand. So my history with 3D printing is long, in the sense that I started in 2015, but Robot Combat is a lot older than that. Robot Combat's been going since the mid-90s and was originally obviously huge in the 2000s and early thousands for Robot Wars and whatnot. But I couldn't find any evidence of people using 3D printing before kind of the RepRap movement, but I'm certain it's out there. So I did ask on some of the forums if anyone's got any experience with 3D printing that predates my own, and of course lots of other people do. We've got some lovely RepRaps here on the bottom corner. That's a screenshot from the Australian forum that somehow, obviously, Photobox tried to take it away from us, but they've still got it online. And in the top right there is a screenshot taken from someone's old Lenovo laptop, because that's all they could manage because it's so old. But it's actually a single piece Antwerp fighting robot one, the small one. It's 3D printed out of nylon SLS, which is from May 2007, which blows my mind. So it's incredibly early. The weapon being essentially the entire main element of the machine is very, very modern, and Tim here was very ahead of the curve. So the point was PLA was fine, but tended to break. ABS very difficult, was a little bit better. SLS9 was viable, but very, very expensive. And as I described, this robot game is about optimization. So if you're trying to turn as much of your chassis into 3D print, you can't afford for that bit to be in the bit of brand school. Tim was very ahead of the game. In my timeline, I had just bought a original Bruce 3 Mark II, the classic, and honestly, pretty much a modern printer. A little bit slower than today's machines, but I still have it. Still works great. Got bed leveling, all kinds of other bells and whistles. And with that, I was able to explore, at least more reliably, some of the better materials. Again, at this point, PLA Pluses are becoming pretty mainstream, and there's a few other materials that are coming online. ABS was still a pain in its stairs, didn't it? I experimented with PTG a lot. So PTG was sort of coming online at the same time as some of those PLA blends as a practical, cheap, nice material. Feels really strong in the hand, feels kind of flexible in a nice way. I don't know if it absorbs shock, whatever it might be. And prints really cleanly. Importantly, it can handle higher temperatures. These robots get hot. PLA will soften, 50 or 60 degrees C. The robots will easily get as hot as that, so it's not viable even for motor mounts, that sort of thing. So I thought, why not try PTG and see if that's better? I proceeded to go mad and build everything out of PTG that I could for my second version of the Robot Pulsar. I used it for battery mounts, for electronics mounts, the actual main switch holder for the robot, and all sorts of stuff. Not super structural, but highly important stuff in my Mark II printer. Put in a huge shift. Now, I learned, like I said, a lot about 3D printing materials a bit earlier on, but I learned an extremely major lesson using PTG that hopefully, if the audio from this next slide works, I'll be able to demonstrate. Doesn't sound like the audio is working, unfortunately.
Yep.
But there you can see that was Pulsar hitting a fellow fighting robot on Robot Wars. This is just literally just an embed of a YouTube video. That's the thumbnail. Apologies. You're meant to have sound, sadly, that has not come through, but you will hopefully have seen in that impact. In fact, if I go to the next slide, you'll see the slide motion. Bear in mind, these robots weigh over 100 kilos, and they are flying across the arena like, they're the size of motorbikes, and they're flying across the arena like flies. So the G-forces, in that exact moment, taught me a major lesson. It's all that goes on in one instead of. And that lesson was PTG is not the one. Every single 3D print, and I'm not joking, every single 3D print I put in that robot turned into glass, effectively. It shattered. Turns out, PTG might feel good in the hand. When you stress it hard enough, it cracks into a million pieces. And for the entire remainder of Robot Wars Series 9, I was taping up the inside of my robot because it had just turned to jelly inside. So PTG, unfortunately, is not the one. The G-force is just too much for it. So that lesson was learned. It's 2017 now. Maybe nylon's an option. So 3D printing wasn't truly unlocked, as you can see, PTG in robot fighting and with PLAs and stuff, still not quite there. So I started experimenting with nylon. Nylon obviously is a very, very strong material. It's also quite difficult to print. So it's a matter of trying to find the right blend. Normal PA6 blends, I don't know about you guys, I always struggle to print them, but some of the better blends that are easy to print, normally you're trading printability for a tendency to crack and it can once again be brittle under impact, and that really is the story here, is that anything that cracks or fails catastrophically is just not viable in fighter carriers. So I was experimenting with nylon. There was a particular type of nylon from another Fulton filament brand called Toolman 3D. They made a particular material called Toolman Alloy 910, and there's several machines down there that still got that in them today. It was the only material really that was the right balance, where it was just about printable, again, with enough effort on your printer at home at that time. I was still using the Mark II. I had to fill it with, I had to cover it, in home insulation, a blanket, and I was drying my filament in the kitchen oven, but I did manage to make some pretty good prints at that time. So this thing, as you can see, this particular robot had exposed 3D printed pulleys now, several counterparts, gears, electronic mounts, so I could actually trust they wouldn't break, and a lot of those are still in use today. Honorable mention to polycarbonate. You might be wondering about polycarbonate. Sort of goes hand in hand with nylon when people think about engineering materials and robots. And it, again, unfortunately, is very difficult to print, but it fails catastrophically. It cracks when you hit it hard at. So we really are on the hunt for suitable materials for robot fighting. So it's critical that you dry your nylon when you print it, because if you don't, it tends to crack. It tends to print badly, sorry. But if you then let that nylon part reabsorb moisture, then it kind of becomes a bit more ductile and more flexible again. So what I ended up doing over the next few years was iterating. By 2023, I and several others in the sport were financially quite a lot of success with nylons, even using them as the entire body of a bigger robot. So it was classic at this point to use PLA, ABS, almost anything would work for the hand weights because of the laws of physics. The smaller the robot, the stronger the materials are in proportion. But as you get bigger, those laws of physics, the square cube law starts fighting you. So in 2023, with Gizmo here, I decided to print the entire chassis in, in nylon, and managed to have some success. It won its first event, outright. I don't know this for sure, but I think I was the first in the UK to win a major beetleweight size competition with a fully 3D printed robot. For reference, all the back stuff that you can see is nylon taller than 910. And I've got another version here of Gizmo, Race Car Vibes Edition. I was at this point obviously fairly comfortable in CAD, and I really enjoy spending a lot of time designing things that look as cool as possible. So I took the unibody thing to the extreme, and again, this robot is this sort of size, weighs 1.5 kilos. They are ridiculously violent and throw themselves around the arena, and I was just about able to make them survive, and this bird did quite well as well. So we're not quite at present day. There's been another revolution that has happened in the sport. There's a lot of people around the world. The US scene is huge at the moment, especially like this era, kind of in the 2020s. The USA went mad for smaller robots. There's a big scene over there. So there's a lot of innovation in pushing the sport as far as possible. So we were taking kind of as community nylons to the extreme, but that search for a material that is never a problem, is never going to crack, was still there, and yet, and ideally one that is easy to print, because that's still a problem. That new era came in the form of TPU. So around 2020, 2022, printers were coming available in the market that allowed us to print TPU and essentially very, very easily. It was definitely possible before, but the modern machines with enclosures and dryers becoming more readily available meant the TPU suddenly online. If you don't know, TPU stands for thermoplastic polyurethane, and it's, as I say, flexible material, and it's basically rubber. And the point of rubber is, if you imagine a rubber ball, say, being hit by a hammer, then the probability is that the hammer's going to bounce back and that ball is just going to squish and that the ball stays still ball-shaped, which is important. If you make your robot out of steels and out of brittle, hard plastics, then the probability is that if they do get damaged, they're going to remain damaged and they're going to bounce back and still potentially be functional. So the very strange thing that happened in 2022-ish is that almost every robot became bendy and floppy. It turns out one of the best ways to protect yourself against the energy of this game is to essentially flop out of the way of the hits of the opponent, a bit like drum boxing. So TPU has taken over, and the whole game changed. In the space of a year or two, as I say, as everyone got access to the better machines from Bamboo and Prusa and everyone else in the game, you could print nylon at home, you could definitely print TPU at home. And so it's essentially the gold standard today still. And the final incarnation of Gizmo, which was that beetleweight robot, which is the one I've got on the table here, is now entirely TPU. The nylon chassis is gone, and I can literally flex this and drop it. I could drop that off a skyscraper and it would just bounce and be absolutely fine. So you obviously need to make sure that you're designing things in such a way that it can't bend into its own way. The weapons and such have got a lot of energy in them. If you design it wrong, and this happens a lot in the sport, about kind of be educated about using materials. If a weapon moves too much, then chances are it will now have the drive bell or hit a gear or something like that. You're defeating yourself. So there's still some tricks you need to learn with TPU, but it is kind of the best material for it. That one I built in 5 days, which is the miracle of 3D printing. It was quite literally a 12-hour print for the main chassis. So I think I started designing it on the Monday. I 3D printed it and started building it to the back end of that week. I entered the competition on Saturday, and by Sunday I managed to win that in two. And that is entirely and only possible because of 3D printing. Going back 5 years even, let alone 10, 15, 20, the idea that someone could design and build something of a relatively good size fighting robot that quickly with this much complexity is just unheard of. So 3D printing has completely changed the game in that sense. Slowly, TPU is taking its war path up the weight classes. So you might be noticing a trend. The small ones we could print for years in viable materials because, again, the laws of physics allow us to do that. But the bigger they get, the harder it is to make materials survive. You obviously need to increase densities and explore some of those design tricks to make sure that everything doesn't just break immediately. And that kind of culminates in this one here, which is the back, which is a robot I built in 2023-24 called Killy Pepper. This thing has got an aluminium chassis, but it is absolutely packed with a mixture of TPU, nylons in some cases, and something to be a bit stiffer. And you can see on the right-hand side, the earlier version has literally got TPU wraparound armor. So that means now the TPU has managed to make its way into being a viable solution for robots that weigh as much as 13 or 14 kilos. Again, you need to make sure that you're using that in a clever way, because if you hit it wrong, then it's going to bend into its own way. And so this cycle continues. That more or less brings us up to today. The change that the sport has seen can't really be overstated. The fact that, as I say, I can design and build something and be fighting with it that same day. We do that all the time at ACU. Patrick downstairs has got a fleet of about 10 amp weights, and I've got a few of mine here today. And I'm not exaggerating when you start designing something in the morning, get the print on, take 2 or 3 hours with the components in it, and you could be fighting with it that same day. And that's just completely mental. So the effects that it's had on the sport can't be overstated. And the truth is that that's entirely, with thanks to we're standing on the shoulders of giants, the RepRap movement, bringing all that stuff home so that we're able to do this, in our own home workshops. And what it might be is meant that enthusiasts like myself could essentially arrive late and just about get it done, but we could just about get it done because our 3D printers are same game. I think that's pretty much it. I hope you think that the ability to design and build robots so quickly is pretty cool. Only thing I wanted to do last was just potentially postulate, what's coming. I'd be interested to know what you guys think in terms of the future. The next trend might be that we're starting to look at method 3D printing. Obviously, that's very expensive, but I'm looking at it, the gears and whatnot for other mechanisms. Maybe printers that can print stuff reliably that are big are going to become more and more affordable. So machines of this scale, we could start to print entire chassis another scale up, as we saw that at John's. Maybe we'll be 3D printing on wiring looms, printing PCBs at home, all sorts of stuff. Who knows what's around the corner. If you've got any ideas and want to have a chat, then I'll be downstairs and I'm happy to come and learn out. To finish, that's essentially all I've got, except I do have, hopefully I've not checked the timer. I've got 3 minutes, which is perfect. Yeah. So if it's all right with you guys, I will do a little demo where I will smash up a tin can with a robot, because you've been very patient listening to me talking about my specific hobby. I think that's all the slides I've got. Yeah, we'll link on that one. The 2 seconds to load this up. So this is a bulletproof test box. I promise you it is safe. It's designed to handle the medium-sized robots in their angriest form. It's going to be completely safe with the little one in there. I know that's what someone will say if they were planning to do something dangerous, but I promise you it will be fine. So I'm just going to open the door. And I suppose if we've got a few minutes, if anyone's got any questions, then feel free to get those ready.
So if you have a question they want to ask, you can hand in the mic. Anyone? I'll ask one. Yeah. Oh, we're going here. Yeah.
Are there any sort of good kits if you want to see people looking for good
kits?
And good kits.
Good kits. One thing I failed to mention pretty much throughout that, I'm obviously here with ACU. We have got some flyers here that you can take a look at. We don't have every single thing that you need in a robot to be able to build your own small one. Yeah, we do have yet. Well, that's part of my hiring. I only joined ACU in October. Part of my hiring is to onboard products that will allow us to buy everything you need from us. But we've got files online to figure out at home and guides and whatever else. So genuinely, if you're interested in building these things, then come and have a chat downstairs. So I'm going to spin this one up. I'm going to turn it off for a second because you can see I've actually lost the wheel, so the tin can has managed to cause some damage. The irony is I work for a Aki does nuts and bolts, and the nut and bolts failed on the back wheel there, but it is a chronic problem that I will fix.
It's because you didn't use a Pepsi can.
It's because I didn't use a lock nut, man. We do sell those. So I'm going to do one more trick before we finish, which is I can get this thing to dance for me. Like I was saying, the physics in these things is completely bats. So this is what we call gyro dancing. So obviously that weapon is spinning fast, but it's spinning out harder. And if I deliberately lose control and try and hit the wall, it's actually quite hard to do because I don't have it. There we go. I want to try and get it to bounce around for you if I can. There you go. That'll do. We'll actually be fighting these against moments that aren't static, although hopefully I won't lose a wheel pretty much the entire time we're here. We're doing workshops with the SF stars. So come and take a look, come and have a chat, and I hope that was interesting.
Amazing.